So let's continue with the last part of this Git session. So let's dive into actual Git and see how we use it. So we'll start with the command line. So let's bring up the virtual machine and the terminal. So I will start by saying that, yeah, we're in our home folder with the usual stuff. Let's start by creating a repos directory where we will keep all repos. So let's go in here and then let's get started with the example. So we create a directory for our project or the project's repository. And then we go in here and we see it's empty. So the first thing we want to do, if we want to use Git to manage versions here, is to initialize this repository. So then it tells us that, yeah, we can, it provides us some useful information and we can read that and use. But we'll see here that, okay, nothing is here. We continue with the example. But actually what happened was that Git actually created this this invisible directory, the hidden directory .git. So ls doesn't print files that start with a dot in the file name. Those are hidden files to avoid clutter. Usually they contain settings and program-specific things. But Git specifically told us that it created a directory here in project/.git. So there it is. But if we just type ls, we don't see it. So the only things we will see when we type ls is the files that are part of the repository, not Git's internal file structure to manage everything. So the next line of the example is to edit a file, and we'll use Vim. And let's see what we want to write here. This is my file. And then let's save and exit. So if you want to use Vim, remember to run Vim Tutor first. That one will bring you a tutorial, and eventually by down here, it will actually tell you how to exit Vim. So kind of crucial to run that one first if you've never used Vim before. Or use Nano, which is the other editor that we've already learned. Now, to add this file to our repository, so we can see it's here, but it's not in the repository. It's not managed by Git yet. We need to add it. So we run git add, and that means, yeah, we have one file that we need to add the next time we commit. And then commit is the command that actually commits this file to history, and then it's in the history and we can't remove it out of history. We can remove the file, but then that will be an action that happens in the history, so we can see that there was a file here and this was what it looked like, but it's no longer here. So we can't erase it from history. I usually add the V option because that one, it's short for verbose. That makes Git actually show you what you're committing, so you can double check that you're not committing something that you don't want in there, or you have forgotten to add something that you were supposed to add. And then it brings up, it opens your favorite editor that you've chosen. In my case, it's Vim here, but you can set Nano. There are separate instructions for that. So just read and follow those. And here it wants me to type a commit message. Add my new file, myfile.md. And the V option, that one actually adds this text here. So it shows that I add myfile.md, and the stuff that is new in it is this line. This is my file. So that's it. And then it's just save and close. And then Git will tell you that, hey, I added this file. This is the reference for this one if we want to use to refer to this particular commit later. We can use that number. So now we can actually see this in history. So we can run git log. And then we see here that, okay, I made a commit at this date, this time. The commit message was at my file. This is the full reference number. So the number we were given here was just the first few digits here, and that's usually enough. And then we can do things like git show, and then we can take this number, and Git will show us what actually happened. So yeah, this is the commit message, and this was the changes that were made. So in this case, we added the file, my file. We can also check the current status of the repository to see that, yep, everything is committed. There are no changes to anything. So the repo is, everything is kept track of. But if we would like to, if we edit my file here and add something, so something like that, now git status will say that, hey, this file is modified. And if we want to see what changes we've made, we can use diff, so as an abbreviation for differences, to show the differences. And we see here that, yeah, this was the old line and it has been changed to this. And then if we want to, if we check the log, yeah, we still have just the one commit. So if we want to commit this change, we have to add it. So we have to add my file again, same as we did before. An alternative way is that since my file is already added, so since Git shows us this difference, we can use git add -p. And this one is also very useful to if you've made a lot of changes and you don't want to add all changes to a commit because some are not ready. So you want to split up your work into several commits, which is desirable. So they are grouped together. You can add git add -p, which is P is short for patch. So then it will actually ask you, okay, so do you want to add this change? Yes, we want to, and that was all. But it might bring up other changes in other files and so on and ask you if you want to actually add them. And then we can do the git commit again. And then we see that the change we made was this. And that's due to the V option we added. Otherwise, we won't. We will just see these things. And then we have a very descriptive commit message. We commit it, and now we can see in the log that, hey, we actually have another commit. So this is the history. So if we want to go back to the previous version, so we can see here, if we print my file, yeah, it's this new one. But we want to go back to the other one, we can actually do that by using this reference. So if we do this, Git will tell us some a warning message that, hey, okay, you're in a particular commit now, so think about what you're doing. And now we see that my file is actually the old version. So to get back to where we were, we can run git switch and then master to go back to the top changes. So now we can see here in my file that, yeah, it's the latest version. So we go to the top of the master branch. So that was a bit of Git. Let's continue with how to actually work with this remotely, because what we did now was just to work on to have this version control for this repository with only one file, my file, and it's only local, so it's only for ourselves. But if we want to collaborate with someone on this particular project, then we would need to have a shared repository somewhere, and that's where GitHub comes in. So I will use KTH Gits 15 system, and I will go to the .intro21 organization. I'll create a repository and I call it Git lecture. Some examples from the video. I will make it public. And note here that we don't want to initialize the repository here because we already have an initialized repository on our local computer. So we're going to just create a very empty repository. And now we want to use the SSH URL like this. If you use the HTTPS URL, the system will actually tell you that IT has disabled this one, and they have a short message for you instructing you how to set it up so you can use the SSH version. So, but if you follow the instruction in the course, that will you will already have solved this problem. So let's go back here and type what's in the slide, git remote add, and the same instruction is also given down here on. So GitHub already tells you how to do this. And then we have the special name origin, which is the default remote repository that we are using. And in our case, we just paste in the SSH URL that we have copied, hit enter. Now we've added that remote. Now we just need to push the current repository that we have done, push it to origin. So that's what the push command does. And now it's the first time I connect to Gits 15, but I've done that, so I know that this fingerprint is correct. I've seen it many times, so yes, but you should verify it through the KTH website, as we've seen before, to make sure. So now what happened here, we see that Git told us that, hey, it created a new branch master, which maps to a branch master. So everything is pushed. So if we go back to the website here and refresh, we see that indeed now we have our file here. And this is my file again, so it's the latest version, and we have only one branch, but we can go back here and then we can see the commits. So we see here that we have the different commits, and here are the IDs that we used before too. So we can go and see this particular version, and we see that, yeah, we added this. So it was the same things that we saw in the command line interface. Same things we can see here as well to explore. So let's continue. The other way, if we create the repository first in GitHub, then we can use Git's clone command. So for instance, if we switch back to the terminal, we can go back here. So we have the project that we did just now. And then we do the git clone, and then we paste the URL. It's the same URL that we just added for the remote, but we give it to git clone. And hit enter, and then it clones the repository. So now we see we have two repositories here, and this one was named Git lecture because it uses the name from GitHub. So if we go into Git lecture, we see that we have my file here. Let's see what it contains. It contains that, and let's see the Git log, and it gets the log from the remote one. So if you create the repository first on GitHub before you do it on your computer, you can just use git clone, and then it will set everything up for you. So two ways to solve the same problem. Depends on what you did. Now let's continue with the slides. So we have seen this already. We have made some improvements, but let's do it again. So we want to make some more changes. So let's add this readme.md, and this is a nice piece of work. Just start editing my file.md. So that is the readme that we want to add. Let's add it and then commit it. So we see here that we add the readme file. And this is nice. So it's nice to have a file called readme.md, exactly those capitals, because what happens then is that GitHub will actually use that to present users with informative messages. So if we do git push, and now that this repository is associated with GitHub, we don't need to write anything more than push. Git will know where to push it. Particularly when you've done a clone, everything is set up, so you just type git push and it will be pushed to the other end. So if we go back here and do a refresh, we see that GitHub automatically uses readme and presents this readme. So now when someone comes into this repository, they know, okay, I should just edit my file.md and have fun doing it. So let's make some further improvements, same as we did before, but make sure everything you write in it is actually good. Save, git add p. So we see now the difference. So this was already in the file, and now we want to add these two lines. So first a blank line and then this line. And yes, we want to add it. And then we want to commit it. We can use the V option here as well to see everything in case we want to go through the changes so we know what we have written to write a proper message. So like we can have a title improves readme. We add some criteria for what goes into my file.md. So it's a descriptive message like this. Save and quit, and Git will commit it, but now it's only on the local one, not on the remote. So we can type git status, and then we see that Git says that, okay, everything is committed, so there are no changes, but the local branch master is ahead of origin master by one commit. So you should run git push to push it. And now if we run git log, we can see that, yeah, we are getting more in our history here. So we see that we have a longer message for this one. And And it's useful to write the commit messages with a title like that. So the first line is title and then a blank line, and then you can type a body, because then it automatically works with Git's short log, which just takes the titles to get a summary of what changes have been made. So let's continue in the slides and see what else we can do. So the next example is going to introduce branching. And this is very useful because then we can start working on several things in parallel. So let's start doing that. So we can, let's minimize this one so it's less clutter on the screen. Okay, so we want to make some changes. We want to create a new branch, so we use git switch and the C option for create. And we name the branch rewrite readme, because that's what we want to do. So it's supposed to be a descriptive name. So now we're on a new branch called rewrite readme. And now we can start our major rewrite of readme. So we can add here, we need some more specific criteria. What is good? Well, it is. And then we start working on this. It's joyful text, but that's not our only criteria, but it's everything we came up with for now. So let's add it. But it's not ready to be merged into the master branch. But now a friend of ours pointed out that, hey, there is a small typo in README that you should fix. So we switch back to the master branch, and now we see that, well, actually, Git now tells me that we switched to master branch and the README's file is modified because we forgot to add and commit it. So thanks Git for reminding us. So we switch back to the rewrite README branch, git add p. Okay, so we did that, but we forgot to run the commit. So let's commit it. Starts on more detailed criteria. Okay, so now we can switch to the master branch and we can have a look at the README file, and it looks just like this. And our friend told us that, well, it's a bit bad to ourselves tell this is a nice piece of work, so we can just remove that one and just have just start editing my file. But it's bad to have this one as a separate paragraph, so we can make it like this. So yeah, and we can break the line there so it's easier to read. So just start editing my file.md, but make sure everything you write in it is actually good. So let's commit that. So we want to add it. Yes, that looks good. And then we commit it. Fixes the README. Not that informative. One should have a better commit message, but that will do. So now we see that the README has this. If we look at the Git log, we see that we have the history like this. Let's switch back to rewrite README. Let's look at the log here. So this one doesn't have the commit that we just did, but it has this starts on more detailed criteria. So if we look at README here, we see that it still has, this is a nice piece of work, just start editing my file. So now we see that this history, these two branches have separated. So we see that we have one version here and one version here, and they have developed a bit in parallel. So what we want to do is to merge these eventually. But first we can git push all of them. So we push even the new branch to GitHub. And now we see that it has created a new branch on GitHub. So let's open here. And here GitHub actually shows us that there is a new branch, README. And GitHub has a workflow of using so-called pull requests, so that you can actually have other people review and comment on this branch before you actually merge it. So that's a really nice feature. I use it a lot when writing documents with my colleagues. So now we want to continue our work, and of course we want to continue building on the improved things that happened in the master branch, in the main line of development. So what we can do here, so we can see which branch we are on by typing git branch. So we see we have two branches, master, and we are currently on rewrite readme. So what we want to do is to merge master into this one, because we want to incorporate the changes that happened in parallel with our work. So what happens is that Git tries to do this, but there is a conflict that we have to resolve. So Git tells us this, that we have a conflict in readme.md. So let's read it. And what happened? Well, turns out that we have two types of text here, and Git couldn't figure out what was part of, in most cases, Git does a great job figuring out what should go where. But in this case, it didn't, so it doesn't know exactly what to do. So our job here is to fix this file so it's as we want it. So we have, this is the version in our branch, and this is the version in master branch. So we see that, okay, well, this was the good stuff we should have in the beginning. So let's move that one up here and then remove this line and this line. And now we're actually set, so we can remove this Git specific stuff. So now we save it. And then we have to mark that we have resolved this conflict, and we do that by a commit. So now we see that merge branch master into this one. And now we have done that. So we can see here, if we look at the README file, now it's actually the nice stuff. So let's add another criteria here. It should be a joyful text, or it can be a funny text. So that's our other criteria. And let's add that and commit it. Adds another criteria to README. So done. Let's get back to the master branch. And now we are done with editing README. So now we want to merge these. So let's see that, okay, this is just the contents of README, but we're done with the rewrite. So let's merge the rewrite into master. And then we hit that. And now we didn't have any conflicts. So now Git knew exactly how to merge these two. So if we print it, we see that it's actually the correct one. So that's how we work with branches and how to deal with different versions in parallel. So git switch, git merge, those are the commands that we want to use. And that was it for this session.